Page 9 in the book and your notes. Geometry 1-1. First thing we're going to discuss today is two review things. The first one is called the distance formula. The distance formula is the distance between 2 points. The distance between 2 points, the distance formula. So what does that look like? Well, let me make a little XY coordinate plane. As a refresher, this is called the x-axis. It's always the horizontal one. This is called the y-axis. Again, it is always uh-oh. I guess I better. There we go. So y-axis, x-axis. And if we have an ordered pair from algebra, it is always in the order of x, y. It's always alphabetical. Easy way to remember it. Alphabetical. Everybody see the front board? Are we good? Okay. All right, so what's this point right here called? Do you guys remember? The origin, yes. The origin, and it has the coordinate of 0, 0. And then let's look at, let's say that we've got a point down here. We'll call it right there. Not a very straight line, is it? Oh, well. And that coordinate would be 1, 2, 3, 4, and then 1, 2, 3, 4, which is negative. Remember, if you go down, it's negative. If you go to the left, it's negative. So the distance formula basically means we're going to find the length from here to there. We're going to find that length. Well, if you continue to investigate this, going over is 4 units. Going down is also 4 units. We went down -4, but can you go a negative distance? No, but that's the direction we're going. And so later on in geometry, we will talk about right triangles. And we could use the Pythagorean theorem to find the length of the hypotenuse. We're just not there yet. So for now then, we've got to use the distance formula. All right, what's the distance formula? It is this. Here we go. D equals, copy this down, the square root of x sub 2 minus x sub 1 quantity squared. And we add, and we do the same thing now with the y's. Y sub 2 minus y sub 1 quantity squared. That's the distance formula. The little sub numbers, x sub 2, x sub 1, all they mean is they just distinguish between the points. That's all. It doesn't matter how we assign them or we label them. For instance, the 0, 0 we could label as x1, y1. And the 4, negative 4, then we would label or distinguish as x2, y2. But I could have went the other direction and it would not have mattered. I could have put this ordered pair up there and this ordered pair down there. AJ, does that make sense?
Yeah.
Doesn't matter. All right, let's find the distance. So now, well, what I'm getting ready to do, I don't want you to do on your paper. Okay, Cooper, just watch. I'm going to make 4 arrows. I'm going to take 4, which is x sub 2. I'm going to put it right there. I'm going to take 0, which is x sub 1. I'm going to put it right there. I'm going to take negative 4, which is y sub 2. And I'm going to put it right there. I'm going to take this 0, y. You guys get the idea? 4 substitutions. That's substitution property of equality that you learned in Algebra 1, which we'll use. Okay, now I'm actually going to do the substitution. I'm actually going to move the numbers. So I'm going to replace these variables. That's a good word for substitution, by the way. Replace. I'm going to replace these variables with the numbers. Ready? All right, let's go. D is equal to, what was x sub 2 again? 4. What was x sub 1? 0. 1d squared. What was y sub 2? Negative 4. What was y sub 1? 0. Let me pause, put my pen down, make sure everyone sees how I did that. Are we good? We good? We good? Yes, yes, yes. People are good? Okay. Now it's a matter of simplifying. Van Buskirk, what's 4 minus 0? 4. What's 4 squared? Very good. Van Buskirk, what's negative 4 minus 0? What's negative 4 squared? Oh, gotcha, didn't they? So we have the square root of 32. Now, that brings us to the concept of radicals. This is a radical. To simplify a radical, you got to know what a perfect square is. Perfect square. Wow, that sounds like a fun term. Here's a perfect square, 4. Here's another perfect square, 9. Here's another perfect square, 16. Is anybody getting the pattern? What's the next one? No. That's not the pattern, Van Buskirk. 25. Who got it? Raise your hand. I didn't hear that. Attaboy, Sanders. How'd you get that? That's right. He figured out the pattern. 2 squared, 3 squared, 4 squared, 5 squared. What's the next one? You guys are bright. 4 squared. I'm sorry, 7 squared. 49. 8 squared. 9 squared. Ooh, let's keep going. 10 squared. How far can we go? 11 squared. Woo! 12 squared. Come on, AJ. 13 squared. 169. Somebody's still going. 14 squared. Whoever did that one, just switch these numbers. 15 squared. 225. Those are what we call perfect squares. Why do we have that? Because they are perfect. Meaning, if I would go in the other direction, what do I mean by that? Other direction, watch. What's the square root of 4? Ah. What's the square root of 9? Ah. What's the square root of 16? Getting the idea? So those are perfect squares. Is the number 8 a perfect square? No, because if I take the square root of 8, is there a number times itself to give me 8? No. You get the idea of a perfect square then. Okay, that being said, let's come back to 32. Is that a perfect square? No, that's between 25 and 36. But is there a factor of 32 which is a perfect square? There is. You guys remember the old factor trees? I could write the square root of 32 as the square root of 16 times the square root of 2. What's the square root of 16, AJ?
4. Right?
Yeah. And square root of 2 is just, square root of 2 is not a perfect square. Don't get fooled by that. 1 times 1 does not give us 2. 1 times 1 gives us 1. So, simplified, it is 4 radical 2. That's simplified. We'll do a lot more of simplifying radicals as the year progresses. Simplifying radicals. Okay, let's do another one with the distance formula. Let's go to page 9. No, sorry, page 10. And look at the problem. Your turn, number 8. Page 10, your turn, number 8. Here's what I want you to find. The distance of RS. Does everyone see the problem in the book? Yes. What? There's an extra one over there. Don't write in it. The distance of RS. What's the coordinate of R? Peebler.
-2 and -2 and 3.
Huh?
For R?
You say -3?
-2 and 3.
Oh, sorry, I misunderstood. You're right. -2 and 3. Peebler, what's the coordinate of S?
4 and 2.
Outstanding. Okay, go ahead and find the distance. Plug them in, substitute them in. Replace the values. Put it into the distance formula. Be careful with your negatives. Hey, again, no negative mistakes. We'll see up the graph. We'll see. Hey, Taylor, make sure you get volume 1.
Yeah, I screwed that up.
Van Buskirk. What's the student in front of you? What's his name? Logan. Does Logan like to be called Red?
I don't know.
Van Buskirk. Does he?
No.
Hey, quietly ask. Logan it is. We could have some fun with Red, but Logan it is. Hey, when you're done, put your pencil down so I know you're done. Okay, let's see how we're doing. Looks like half of you are about done. 4 minus a negative 2. That's 4 plus 2. That's 6. 2 minus 3. Negative 1. 36 plus 1. Should have gotten the square root of 37. If you got it right, raise your hand. Oh boy. Not enough. If you weren't done, I understand. Let's try another one. Let's, on the same problem, your turn number 8. Let's find the distance of the segment PQ. You don't need a calculator. Okay, let's see how we did on this one. What's the coordinate of P, Cooper? Cooper, what's the coordinate of Q? Very good. Does not matter which one we assign. X sub 2, Y sub 2, doesn't matter. But once we assign it, we got to stick to it. Okay, so here we go. Yours may not look exactly like mine. If you didn't win a different sign, it's okay. Don't forget the square root. Square root of 40. Who got the correct answer? Much better. Much better. Okay. So the square root of 40 is actually not a reduced answer because that could be factored. Let me find a little space. Let me do it here. You guys see that all right? Where's 40 at? There it is. So if I go to the square root of 40, I could actually reduce it, factor trees, the square root of 4 times the square root of 10. Remember those perfect squares I was talking about? Square root of 4 is 2. The square root of 10 is not a perfect root. So that would be simplified. Now eventually we'll also be able to use a calculator and get a decimal. But there's no need. Okay, put your pencils down. Let's see if you guys can do some of this math in your head. Here we go. You ready? Ready? Everyone says it out loud. Thank you. Could you see that? That wasn't very clear, was it? All right. Let's do this. All right, so those are just some common type of problems that you should probably get 99% of the time. Okay, so be very careful with your negatives. All right, we're going to do, no, I think we're good with distance formula. Let's move on to the next topic. Next topic is the midpoint formula. The midpoint formula is this. It's actually an ordered pair. Okay, the midpoint formula is an ordered pair. So I'm going to start with parentheses. Now I'm going to put a comma in between. Midpoint formula is an ordered pair. You take the x values and you add them together. Divide by 2. You take the y values and add them together. Divide by 2. And that is the location or the coordinate of the midpoint. Somebody out there, give it a shot. What would be your definition of a midpoint? It's all right, just speak up. Good. It's the middle point of a line segment. Or you could say it's halfway. Distance between 2 points. It's right in the middle. Okay, so we all know what a midpoint is. So there's the midpoint formula. Okay, so stay on your turn, number 8. And now let's look at JK. Find the midpoint. Go. Lily, what's the coordinate of J? I can't see it. Huh?
I started counting by ones and not by two more copies.
All right, let me know when you get it. Well, I think it's just once. You don't have to count them by twos. It's just -4, 4. So go ahead and give me K when you get it, Lily. Thank you. Logan, what are the two values for x's? No. This is an x and that's an x. Very good. So add those two together, divide by 2. Van Buskirk, what's -4 plus -2? What's 4 plus 1? Van Buskirk, reduce those. What's -6 over 2? You're right, it's over 1, but I don't have to write it, right? It's over 1. Okay, good. Yeah, that's fine. We'll take the decimal. Very good. Who got the right answer? Not bad, not bad. If you missed it, make sure you see what you did wrong. Let's do one more and we'll be done for the week. Let's find the midpoint of LM. Find the midpoint of LM. Naomi, help me out. What's the coordinate of L? My eyes are bad. I can't see. Very good. -1, -4. Naomi, what's the coordinate of M? Very good. Good job. Find the midpoint between those now. Hagen, I'll add some teeth for you.
Okay.
It's like a portrait. one, right? I mean, Landon, that's really good, isn't it? All right, here we go. What do we do? Find here. Add these together. What's -1 plus 2? What's -4 plus -2? Everyone see how I did that? Who got the correct answer? Really good.
I did it without that.
Do it in your head.
Yeah.
No assignments.